Okay, section 13.2, the first half of it, derivatives of vector functions. This is sample problem number 19, and in it we're asked where on this vector function is the plane parallel to this plane also perpendicular to RT. Now in essence that means the plane that's unstated, the plane parallel to. If it's parallel to this plane, then it contains its direction numbers. So in essence, we want to know when the direction numbers from this plane are also running in the same direction as the derivative of RT. Because if they run in the direction of the derivative of RT, that makes this plane perpendicular to RT. And of course, if it's parallel to this one, that means it uses its direction numbers. So in order to see that, what we want to look at is what the direction perpendicular to it is going to be. So I want a normal for this unknown plane to be 6, 6, negative 8. And I'm going to save myself a little bit of trouble here. I can actually reduce that to 3, 3, negative 4, because the only purpose for this is to provide a direction, and proportional vectors point in the same direction. I didn't care about the magnitude of the normal. It didn't do anything for me. So this reduces it. Well, now let's find r prime of t, because what I in essence want to know is when that points in the same direction as this vector. So r prime of t is going to be equal to 3t squared, 3, and 4t cubed. And now in essence, it's just a question of matching these things up. So let's look carefully. I want these to be the same. So I want t to be such that 3t squared is equal to 3. 3t squared is equal to 3. Well, one possibility for that, of course, is plus or minus 1. So t could be equal to plus or minus 1 and make that true. The middle component's no help. It's 3 and 3. Basically, since this is not a function of t, it always matches up and it doesn't help me restrict t. Okay, finally, the third one, 4t cubed is equal to negative 4. Well, this is only going to work when t is equal to negative 1. The positive one will actually produce a positive 4. So now I know that the positive version of t is out. It has to be the negative one. And there it is. T being negative 1 actually satisfies all three conditions. So now at the point t equals negative 1, we know that the direction of this particular vector points perpendicular to this plane, which is parallel to the plane we're after. So now we can find the point. We go back to the original function, r of negative 1. And of course, that's going to be negative 1, negative 3, and positive 1. So there it is. That's the vector, and of course it points towards that point. So we can also say the point negative 1, negative 3, and 1, that's the location on RT. It's when t equals negative 1, it's at this particular vector, and it's at this particular location.